All right, guys, how you doing? Today we're going to take up our chemistry homework that we were left with. So, just to speak really quickly to you, I am away. I'm away today. So here I am tonight, getting this video recorded, walking you through yesterday's homework, and then I'm going to leave you with some more practice today. I just want you to get some practice in drawing Lewis diagrams and thinking about this stuff, and then one way or another, tomorrow we're going to do the next lesson. So either I'll be back in person, which would be great, or I'll still be away, in which case I will pre-record the lesson and we'll learn it that way, though I'd rather be in person because it's kind of a tricky one. But in the meantime, today, we're going to take up the homework. We'll give you some look at that. And then after we have done that, I'll leave you with some new practice to work on. So with no further ado, let's take a look. So yesterday we went through drawing Lewis diagrams. And make sure if you weren't here that you kind of go through that topic and make sure you understand it. This is the big one. We want to be able to draw a Lewis diagram even for a complicated molecule. And if you don't recall, like we said yesterday, yes, some of these seem pedantically easy and you might find yourself saying, why am I going through all these steps? I could have just followed the rules we learned last year, and that's true. But if you learn to follow these steps, when you get to a complicated molecule that doesn't work immediately, you'll still be able to do it. Okay, let's try the homework. So this first example is just actually going to follow the rules you would exactly expect it to. So this will be one of those examples where when all is said and done, you kind of say, why did I bother doing a complicated version of this? Because it just follows the rules. But that's okay. It's good practice. So if we look at phosphorus, phosphorus has 1, 2, 3, 4, 5, 6. Is that true? Now I want to double check. I'm tired. 5. 1, 2, 3, 4, 5 electrons in its valence shell. And 3 bromines, well, each bromine, in terms of its s and p orbitals, in terms of its electrons, has 7, right? Because we've got 1, 2, 3, 4, 5, 6, 7 electrons in the orbitals that we consider octets, right? In the s and p orbitals. So 3 of those would be 21 electrons, and there's no charge, which means we're talking about 26 electrons. So we would draw phosphorus in the middle. We would draw our 3 bromines. We would complete the octets around each of these, just like that. And then we would count. And if we count, this will give us 8, and this will give us 8, and this will give us 8, and that brings us to 24. But we don't need 24, we need 26. So we're going to need 2 more electrons, and we're going to put them right there. And if we look, that is complete, right? Everything has 8 electrons around it, so that's a complete octet, so that's good. Nice, easy one. And again, that's one you could have drawn just by saying phosphorus likes to make 3 bonds, bromine likes to make 1 bond, but that's okay. I want to show that this process works. This next one's another example like that. We totally could have just followed the old rules. We know that carbon likes to make 4 bonds, hydrogen likes to make 1, but we're still just getting practice. So if we look at carbon, carbon has 4 electrons in its second shell, 2 in the s, 2 in the p. So carbon's going to give us 4 electrons, and hydrogen's going to give us 1 electron each, but since we have 4 of them, it's going to give us 4 electrons for a total of 8. We'd put carbon in the middle, and we'd put the 4 hydrogens around it. We will put why did I do that? We will put a single bond between each of them. And in doing so, that is 2, 4, 6, 8 electrons. The hydrogens already have complete octets because they're in the first shell, so they can only get 2 electrons. That's done. Nice and boring. Nice, easy ones. Okay. Third example, the nitrite ion, NO2 -1. Let's count this as well. Nitrogen will give us 1, 2, 3, 4, 5 electrons in its valence shell. And 2 oxygens will give us 2 times 6 is 12. And the charge is going to require 1 more electron for a total of 18. Let's see what that looks like. So we're going to put nitrogen in the middle. We're going to put an oxygen on each side. We're going to draw a single bond. Then our practice is going to be to complete the octets of the surroundings. And then to count. And of course, right now, that will be 8. There's 8 more for a total of 16. But we don't need 16 electrons, we need 18. So there's going to be 2 more to go. And they can't go on an oxygen, they're already full, so they have to go on the nitrogen. Now you will note, this needs another pair. And so it's going to form another bond here. And that represents our first double bond. So everything we've seen so far has been a sigma bond, but now here we have our first pi bond. Good. All right, there it is. Actually going to erase that because the question doesn't really ask that. It gets messy, but a good thing to know. All right, we have C2H4, and it tells us to just put both of the carbons in the center. So, okay, when we go to count, 2 carbons, each gives us 4, so that's an 8 electron. 4 hydrogens, each gives us 1, so that's 4 electrons for a total of 12. And I think this is going to be nice and easy. We have carbon, carbon, hydrogen, hydrogen. And I don't want to put a third there because then I could only put 1 coming off of that carbon. So we'll make it symmetrical like that. When we go to complete the octet, well, the hydrogens are already there. So now let's count electrons. 2, 4, 6, 8, 10. So we need 2 more. It doesn't matter which carbon I put it on because no matter what I do, we're missing electrons right here. I have no more electrons to put because we only have 12. So these are going to get shared. And in the process, that will form a double bond, just like that. And again, we would have a sigma bond, 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 and it is only this one here that would be a pi bond. Again, I'm not going to leave those in because the question doesn't ask that, but just to make sure we understand it. And one last example, N2H2, dinitrogen dihydride. And 2 nitrogens would give us 10 electrons, right? Look at nitrogen. 1, 2, 3, 4, 5. And 2 hydrogens give us 2 electrons, and that puts us to 12 electrons total, just like the previous. So we would put those nitrogens centrally, a hydrogen on each side, and then that's 2, 4, 6, 7, 8, 9, 10, just like that. 2, 4, 6, 8, 10, and we want to get to 12. So we'll go like that. And now, of course, we're still missing a pair here. So these will get shared to there. And so this will be a double bond between them. And there we go. Those were our Lewis structures for homework. So this is certainly not the most exciting work we want to get, but hopefully it feels a little bit on the straightforward side, and I'm going to give you a bit more practice to work on. Again, to repeat myself, tomorrow we're going to move on to the next lesson where we're going to actually look at what's happening in the orbitals when we bond like this. I hope that'll be in person, like I said, but if it's not in person, we will do it remotely. Have a great day, guys. Ciao.